the most important things that you need to prepare for interviews, especially whiteboard rounds, is DSA, data structures and algorithms. To the next topic, which is big O, time complexity. This is one of the most critical aspects of solving a problem during the interview process. Let's take an example to understand this concept better. Suppose we have an array of integers, and we need to find if there are two numbers in the array that add up to a given target number. We can do it by iterating through each element of the array and comparing it to every other element in the array. In this approach, we will iterate through the array n times and compare each element with all the other elements. Therefore, the time complexity of this brute force solution will be O. Now, let's see if we can come up with a better solution. We can use a hash map to store the numbers in the array and their indices. Then we can iterate through the array only once and check if the complement of the current element already exists in the hash map. If it does, then we have found a pair that sums up to the target number. The time complexity of this solution is O because we are iterating through the array only once. Now suppose another interviewer asks, what is the time complexity of the first solution? You should be able to say that it is O. And for the second solution, you should say that it is. You should also be able to explain why the second solution is preferred over the first solution. And you should also be aware of different kinds of big O complexities like O, and so on. Next, system design. System design is typically part of mid-senior level interviews. It focuses on designing scalable and maintainable systems that can handle a large number of users and data. A few basics that you need to know are client-server architecture, load balancing, caching, and sharding. As a developer, it is important to understand how these concepts work and how they fit together to form a complete system. For example, you should know how to design a simple web application that can handle a large number of concurrent requests. You should also be familiar with different types of databases and when to use each of them. In addition, you should know how to design a scalable and reliable messaging system. Finally, you should also be familiar with containerization technologies such as Docker and Kubernetes. Let's discuss some of the core components of a typical system. First, APIs. Application Programming Interfaces, or APIs, allow different software applications to communicate with each other. APIs are the building blocks of modern software systems and are used to connect different applications and services together. They allow developers to reuse code and functionality, making it easier to build complex applications. APIs can be used to perform a wide range of tasks, such as retrieving data from a database, authenticating users, or processing payments. When designing a system, it is important to consider the different types of API that will be used and how they will be implemented. Second, databases are used to store and manage data. There are several different types of databases, including relational databases and NoSQL databases. Each type of database has its own pros and cons, and it is important to choose the right one for the particular application. Some factors to consider include the type of data being stored, the size of the data set, and the expected workload. In addition, it is also important to consider the scalability and availability of the database system. Third, message queues. Message queues are used to send and receive messages. This allows different parts of the system to communicate with each other without having to be directly connected. Message queues are often implemented using technologies such as Rabbit. It is important to consider the different types of messages that will be sent and received and how they will be processed. Fourth, content delivery networks, or CDNs. This helps to improve the performance of web applications and reduce the load on the origin server. CDNs are often implemented using technologies such as Varnish or Nginx. Fifth, microservices are a way of organizing an application into a number of small, loosely coupled services. This allows the application to be more scalable and resilient to failure. Microservices are often implemented using technologies such as Docker and Kubernetes. Now that you know the core components of a system, let's talk about some of the design questions that you might be asked during an interview. Design Twitter. Design a URL shortener. Design a system to handle Uber-like ride requests. These are some of the examples that you can expect. The key thing to remember when answering these questions is to focus on the trade-offs involved in your design decisions. For example, when choosing a database, you need to consider the trade-offs between scalability and performance. Lastly, behavioral interview preparation. Most interviews include a behavioral component where the interviewer asks you questions about how you work in a team setting, how you handle conflicts, how you handle failure, how you deal with ambiguity, etc. These questions are designed to assess your soft skills and how you work with others. To answer these questions effectively, you should use the STAR method. STAR stands for situation, task, action, and result. This is a structured approach to answering behavioral interview questions that helps you to provide specific and memorable examples of your skills and experience. Here are some of the stories that you need to prepare for. Stories around conflict resolution, working in a team, failure and learning from it, leadership or ownership, and time management. Finally, let's talk about how to approach the whiteboard round. Here are 5 tips that you need to keep in mind. Tip No. 1. Think out loud. By thinking out loud, you show the interviewer your thought process and reasoning behind the solution you are proposing. This helps them understand your problem-solving approach even if you don't reach the correct solution. Additionally, thinking out loud helps you to organize your thoughts and articulate your ideas clearly. Tip no. To start by clarifying the problem and discussing edge cases. Before jumping into coding, take some time to discuss the problem statement with the interviewer. Clarify any ambiguous requirements and ask questions to fully understand the problem. This may also involve discussing edge cases and boundary conditions that need to be considered. By taking the time to clarify the problem up front, you can avoid unnecessary rework later on. Tip no. 3. Write clean, modular, pseudocode before jumping to When faced with a complex problem, it is tempting to immediately start writing code. However, this approach can lead to a lot of debugging and frustration. Instead, take the time to write clean, modular pseudocode before writing actual code. This will help you to break down the problem into smaller, more manageable chunks, and will make it easier to spot errors or areas for improvement. Modular pseudocode is also easier to read and understand than raw code, which can help you communicate your thought process to the interviewer. Once you have written your code, it is important to test it thoroughly. One way to do this is to run through a few test cases manually yourself, before running the code with a bunch of inputs. This can help you to identify any issues with your code and build confidence in your solution. It also shows the interviewer that you are thorough and detailed. Tip no. 5. Be ready to optimize and discuss tricks. In many cases, the interviewer will want to see if you can optimize your solution for time or space complexity. Even if you have already written a working solution, be prepared to discuss potential optimizations and tricks. This may involve using different algorithms or data structures, but it may also involve making design decisions about the system as a whole. For example, you may need to decide whether to use an in-memory database or a disk-based database, or whether to use a centralized or distributed system. By being prepared to discuss these tricks, you can demonstrate your ability to think critically about the problem and to come up with innovative solutions. So now you have everything you need to know about the interview process. Good luck, hope you enjoyed the video. Please drop in your comments and feedback below. Thanks for watching and see you in the next video.